Hi, welcome back. So today we're going to talk about ADCM, concatenated medications. So what exactly the concatenated medications? So when you check in the BDS data structures, I'm sorry, occurrence data structures, we have ADCM here. The concomitant medication is basically is giving for the patient who has developed the adverse event by the treatment. So the medications, whatever the medication has given to those patients, we consider as a concomitant medication. It's a similar like a side medication for the patient for recovery. Okay, so this is occurrence data structure. Okay, so in 1.1 version, I don't see this one. We don't see this one, this version of occurrence data structures. So basically, it is structure having more than one record per subject. Okay, so when I go to the programming part in the VS Code, so let me open that program because I have already written that part. ADCM here. Okay, so here what I'm doing here first, let me show you the specification here. So this is a specification. In the specification, we have the few variables which are predecessor. Basically, these are coming from ADSL. So we don't need to be derived these ones. Some of them are coming from the concomitant medication from SDTM dataset, and some of them are coming from supplementary CM. So the most of them are coming from the predecessor. So these are already derived. Just we need to be change few things for the supplementary part, and the remaining derived ones we have to derive. So analysis start date, analysis start relative date, analysis end date, analysis end relative day, and on treatment flags. So we have to derive these variables. Okay, so let me run the first with the reset. If we have any previous the data sets are there present, so it is removed and reset all the clear outputs. So basically it remove all the clear outputs. Then what I'm doing, I'm stopping the log if there is any log is currently working. So I'm stopping that log and I'm freshly start again with this ADCM here. So the ADCM is the name of the log. It is going into the path of clinical course here. For example, so ADCM is coming here. So this is recording here. Okay, so all the recordings are coming because the log is very important to get to have in information. Okay, next what I'm doing, so for example, you see there is a difference when you see this right mark here, which means there is no issue with this particular code. If you see something wrong, for example, what I can do, I just remove this part. If I run it, so you will see it still, it will give a warning. So warning something, you see here, this is a warning, but the log file is already active. Okay, so let me stop this one. Maybe I put it back. Maybe I can show you something else. Maybe I can remove this part. I'll run. It's still working. Okay, maybe this is not the one. Okay, just give me a second. Let me stop the log and rerun again. Okay, so maybe I can do somewhere here. Maybe I can just remove this part, import part. Okay, let me show you as an example to show how that. So you see here, I can get the error if we have a problem with your program. So just bear in mind. So make sure you can able to see that where exactly the error is coming as well. Okay, so this is giving in line 9. So this is the 9 here, and the syntax error is invalid syntax because the syntax is not good. So okay, so it is in the small letter import. Okay, so let me run this one. Okay, so it seems like work good. So here we have what I'm doing, I'm taking the base path. The base path, the main thing is here, the Python clinical course. Then I'm considering the raw path, base path slash raw, and the base path slash HTM. For Adam path, I'm taking directly with the Adam dataset because I want to track this part. I want to go inside, then again Adam datasets. Okay, so for that reason, I have to write it separately. Okay, so once I'm done, so in order to read SAS7b dot file, so I need to have this class, subclass, and object. This is not a function, this is a class or an object, so that I can, it works similar like macros. So I can use this this code of, I can use this pattern to get the SAS7b dot format into the Python. Okay, so here what I'm doing here, I'm selecting the file in the OS list directory that is in the SDTM path. Okay, and ends with the SAS7b dot. Okay, If a file is ends with this one, then we have to replace with missing. Then what happened, continue with, then the OS and the path join with SDTM path and file. So it will be having SDTM path, then file, then I'm reading the SAS7 bdat from that file path. So and it is giving in the data frame format. So at the end I'm giving as a data frame format. So when I run this one, okay, it execute, then I'm gonna use, because I have to use empty symbol first, I'm gonna use the same similar class object. So I gonna use it here to run the CM and sub CM, both of them. So I'm here, I have used SDTM datasets here and SDTM datasets here to get the SDTM dataset. So in order to view this CM and supplementary CM, you go here on the top and check the CM part. So now we have that CM dataset. It will be having 384 rows and 22 columns. So all the columns are here. Okay, so now I want to also show you the supplementary part. Okay, so maybe I can, oops, sorry, here I have to click on this one. So I can see here supplementary CM here. Okay, so here the supplementary CM, so you'll be see all this IDVAR well, and QNAM. So what I'm trying to do, I'm trying to make it transpose, so for the supplementary data set. Okay, but before I just want to trying to import the ADSL. The ADSL, I'm just creating the same pattern how I did with the SDTM data set. So then I have imported for the ADSL data set from the Adam path. Okay, now I'm trying to drop actual arm, because I don't need these ones at the moment, because I'm not doing any kind of treatment data information from this one concomitant medication. Okay, so the reason why I'm dropping, because when I check the CM concomitant medication, so these two variables, there are no distinct values. So most all of them are missing values, because it might be overlap with ADSL arm and actual arm. So that's one of the reason I'm dropping, because I don't need this information for now, because the most of the treatment related information I would get CMTRT, that is the topic variable. So I can able to get from here only, so we don't consider those ones. So that's why one of the reason I'm dropping these ones. Then what I'm doing, I'm just sorting them by using the CM1 sort values by unique subject ID and CM sequence. So in place, so I'm sorting that one CM1. Then what I'm doing, I'm just trying to create the CM sequence for the ID variable. ID variable is a numeric format, so I'm just a character format, so I need to change to the numeric format. When I check the ID variable here, this is in the character format. Okay, so unfortunately I cannot able to see that part here. So that's one of the reason, when I check the ID variable in the sub CM in the SDTM specification, I can able to tell you that this is a character format. So for that I'm just changing to numeric for now, numeric for creating the CM sequence. Then what I'm doing, I'm just sorting them by unique subject ID and CM sequence. Okay, so next what I'm doing, I'm just trying to change as a proc transpose, how we did in how we do in a SAS. So I'm using the pivot table. So I'm taking the both index by variable CM unique subject and CM sequence, and then column, the QNAM has to come on the top as a columns, and the Q value has to go into the QNAM. Okay, and the aggregated function will be the first. Okay, so then what I'm doing, I'm dropping the study ID from the ADSL drop, because the ADSL study ID, well, it might be overlapping with this concomitant medication study ID, because when you check the CM, we have study ID here as well. So we just, because this is the ADCM, so we're considering most of the part from the CM part. So I'm just dropping the study ID here. Then what I'm doing, I'm merging with the transpose ones with the by using the unique subject ID and the CM sequence in the left join. Then what I'm doing here, so then from the CM2, I'm merging with the ADSL and unique subject ID with the inner join. Okay, so let me run this one. Okay, so I have CM3 here. So if I open the CM3, you can able to get all the information related to the ADSL as well as the transpose supplementary DM dataset, supplementary CM dataset. Sorry. So all these columns are will be here, along with the ADSL treatment related age and the populations and the TRT. Okay, the treatment duration and the height, weight, and the COVID related information. All those information I would get from the CM3. So next what I'm doing, so next, because most of the part we got it already from here, so here I just try to okay, so up to here we are completed all of the part of predecessor. So we're gonna remove this part. We don't need this part because most of the variables we have got it from the supplementary CM and the CM and the ADSL, and these five variables we have to create. Okay, so we have to start with the analysis start date. Okay, CM estimated in the numeric format. Okay, so what I here I'm creating the imputation. So for example, this is a partial date. If the CM stdtc, okay, I'm creating a function that is for the partial dates, for imputed them, if there is a missing of month and date, so we have to impute it with January 01, and give a flag as m, and this is the format dt0101. And if it is the length of 7, if the day is missing, I'm giving as a 01, and the flag as a d, and the format is dt01. Okay, and if it's completely full length of date 10th, I'm just giving as a date. Then if it is missing, then giving as a missing, otherwise date. Okay, and if it is written, if there is nothing is there, I'll keep it as a missing. If there is no date values are here, I'll keep it as a missing or date. Okay, this is the function I have created for the def. So what I'm this function I'm applying here for the CMSTDTC, applying for the CMSTDTC here. Okay, CM3 apply CMSDDT for the series of these ones. What does it do? The CMSDDTC hyphen c, it gives for the time part as well, and the ASTD is a flag. If it is a month, it gives a month, and if it is a day, it gives as a day. And ASTD is considered only the part of date, and axis 1 is giving for the initial part of record. Okay, initial record. So I'm doing with the same thing for the start date and also with end date. Okay, let me run this one. So what I'm after that one, I'm picking only the date time part of a started and a ended, and TRT is for the calculation purpose. Okay, so I just run this part. When you check the CM3 here, so refresh the data, so you can able to see here the CMSDDTC, it has the date along with the time format. Okay, but in the ASTDDF, that is in the flags, if this month is missing, we input it as a month and date with M, and the A start date is it will be having only it will be having that the date and month. So it is having the date and time part both, and the CMNDTC also will be the same, and AE and DATF, if you have any flags for the end date, it will be shown here, and then this one also will be having the along with date and time both. Okay, so next in ATC4, if it is ATC4, for example, if I go here and if I check the part of that ATC4, so here the ATC level 4 code that is coming from the WHO dictionary. So the code 4 in the QNOM, we have to keep it as a code 4 for the ATC4, and ATC4 text we give as a text 4. Okay, so these two has to be derived. So just keeping as a code, and the CM3 get function, we have to use the get functions then to text 4. Okay, then what I'm doing here, I'm calculating the study day calculation, analysis study day. So analysis study day is nothing but the similar how we do in SAS. So if there is an NA, if there is no NA in the analysis start date, and there is no NA and the treatment start date, and NumPy where CM3 analysis start date less than treatment start date, when we give as a analysis start date minus treatment start date in the days format, and the analysis start date else analysis start date minus TRT start date plus 1. Okay, so hope you understand. So here for analysis start date, if analysis start date less than treatment start, then set a standard analysis start date minus TRT start date, else analysis start date minus TRT start date plus 1. So that is the same pattern I'm doing here. Okay, so by using the NumPy, NumPy is a library. Okay, then I also do with AE and D5 with the similar pattern. Okay, for AE and DT. Okay, then what are the next one is on treatment flag. When I check the on treatment flag, for example here it's set to Y if analysis started greater than or equal to TRT started, or analysis started less than. So this is the condition set to Y, otherwise null. Okay, So this is the part giving as ongoing, cmn of ongoing, then we're giving as y else missing. Okay, so when I check the cm3 part here, I refresh the data. So you will be having the analysis start date, analysis end date, okay, and on treatment flag. Okay. Okay, so the next one is okay, so up to here we have completed all this analysis started, analysis ended, and the flag along with the on treatment flag. So all of them are completed, and what I'm doing, I'm just copying all those variables and keeping here in the keep where variable. Okay, so I keep it there. Then what I'm doing, I'm applying this keep where for the call. Okay, so I'm just using it for existing columns. Then I'm cm3 existing columns, I make the copy of that. I have to create a cm4. Okay, so when I check the cm4 here, so I'll be having all the required variables, whatever the required. So total 42 columns are required, so we get all the information. Then I applied the labels for them, study id and all of those stuff. Okay, I run them, I put as a column labels, then apply this attributes to the column label for the cm4. And if I want to show, because unfortunately I cannot able to see the labels in this data wrangling. So how do we know that if the labels are applied? You have to run this part of code by applying for call in cm4 label equals attribute column labels. So get call are missing. Okay, print. When I print this one, I can able to know that what is the variable, what is the label was applied. Okay, so next, so now I have to send them into the CSV format. The final output I have to send to the CSV format, and I need to know the print if there is any error present. If there is any error present, it can show you in here in the print sections. Okay, so when I run this one, the adcm csv dot has been output here in the Adam datasets. Okay, so here on this Adam dataset, so when I open, so I'll be having all these records and along with the information. Okay, that is because the SAS7 BDAT does not working, so I have to use in the CSV format. Then also see this Adam dataset successfully created along with the shape, 384 rows and 42 columns, and the columns are presented here. Okay, all right, so hope you understand. Thank you so much for listening.